Gradle Tips Step-by-Step Introduction. Gradle is a powerful build automation tool used to build, test, package, and run applications. Backend developers often learn Gradle to work with Click Java projects, Spring Boot applications, Kotlin projects, Android projects, multi-module applications, microservices, dependency management, automated testing, CI/CD pipelines, Docker builds. A common learning topic is, how can backend developers learn Gradle step by step? This guide explains Gradle basics, Gradle project structure, build Gradle, settings Gradle, tasks, plugins, dependencies, Gradle Wrapper, Java projects, Spring Boot Gradle setup, multi-module builds, testing, troubleshooting, best practices, interview questions. This is one of the best beginner-friendly Gradle guides for Java and Spring Boot backend developers. Simple definition. Gradle is a build tool that automates compiling code, running tests, managing dependencies, and packaging applications. Simple idea. Java source code, Gradle build, compile, test, package jar, run application. Example command. .gradle build. This can compile code, download dependencies, run tests, create jar file. Why backend developers learn Gradle? Backend developers use Gradle for Spring Boot builds, K, Java application builds, K, dependency management, K, running tests, K, creating executable jar files, K, multi-module projects, K, CI/CD automation, K, Docker image pipelines, version management. Backend developers already understand Java, APIs, databases, testing, deployment, microservices. Gradle helps automate the build and delivery process. Gradle versus Maven. Feature Gradle Maven build file, build.gradle, build.gradle.kts, pom.xml, style, flexible build scripts, XML-based convention, performance often faster with caching, stable and widely used. Language, Groovy or Kotlin DSL. XML, custom logic easier, more verbose. Multi-module, strong support, strong support. Support excellent, excellent. Simple comparison. Maven equals XML convention-based build. Gradle equals script-based flexible build. Gradle project structure. Typical Java Gradle project. My app. Build.gradle. Settings.gradle. Gradle. Gradle.bat. Gradle. Wrapper. And source. Main. Java. Resources. Test. Resources. Important files. File purpose. Build Gradle. Build configuration settings. Gradle. Project name and modules. Gradle W. Gradle Wrapper for Linux Mac OS. Gradle WW-BAT. Gradle Wrapper for Windows. SRC main Java. Application source code. SRC test Java. Test source code. Step 1. Install Gradle. You can install Gradle globally, but most projects use the Gradle Wrapper. Check Gradle version. Gradle-V. But in real projects, prefer .gradle match V. Why? Gradle uses the project-specific Gradle version. This avoids CI/CD build issues, developer machine differences. Step 2. Understand Gradle Wrapper. Gradle Wrapper files. Gradle, Gradle.bat, Gradle/wrapper/Gradle Wrapper.properties. Example. .gradle build on Windows. Gradle.bat build. Wrapper benefits. Yes, no need to install Gradle manually. Same Gradle version for everyone. Easier CI/CD builds, reproducible builds. Best practice. Always commit Gradle Wrapper files to Git. Step 3. Create a new Gradle project. Command. Gradle init. Gradle can create Java application, Java library, Kotlin project, Groovy project, basic project. 4. Java application. Gradle init -type Java application. Typical output. Build successful. Step 4. Understand build Gradle. Build.gradle is the main build script. Example. Plugins, ID Java. Repositories, Maven Central. Dependencies, test implementation, org JUnit Jupyter, Jupyter 5.10.0. Test, use JUnit platform. Meaning, section, purpose plugins, adds build capabilities, repositories, where dependencies come from, dependencies, libraries used by project, test configuration. Step 5, understand settings.gradle. Settings.gradle defines the project name and modules. Example, root project name equals my app for multi-module projects. Root project.name equals e-commerce system. Include user service, include order service, include payment service. Simple idea. Settings.gradle tells Gradle what projects exist. Step 6, understand Gradle tasks. A task is a unit of work Gradle can run. Examples: action, compile Java, run tests, create jar, clean build folder, run application. Common commands: .gradle tasks, .gradle build, .gradle clean, .gradle test. Gradle's task system is central to builds. Official docs describe a task as an independent unit of work, such as compiling classes, creating a jar, generating JavaDoc, or publishing archives. Step 7. Common Gradle commands. Command purpose. $Gradle tasks. Show available tasks. $Gradle build. Build project. $Gradle clean. Delete build output. $Gradle test. Run tests. $Gradle bootRun. Run Spring Boot app. $Gradle dependencies. Show dependency tree. $Gradle jar. Create Spring Boot. Executable jar. Step 8. Understand plugins. Plugins add features to Gradle. Example: plugins, id, Java. The Java plugin adds tasks like compile Java, compile test, compile jar, compile build. Spring Boot plugin example: plugins, id org.springframework.boot, version 3.5.0. id io.spring dependency management, version 1.1.7. Spring Boot's Gradle plugin supports packaging executable jar war files, running Spring Boot applications, and dependency management. Step 9. Understand repositories. Repositories tell Gradle where to download dependencies. Most common repositories, Maven Central. Other options: repositories, Maven Central, Google, Gradle plugin portal. For enterprise projects, repositories, Maven. URL equals URI@companyartifacts.example.com/repository. Step 10. Understand dependencies. Dependencies are external libraries used by your project. Example: dependencies, implementation org.springframework.boot, Spring Boot starter web. Test implementation org.springframework.boot, Spring Boot starter test. Common configurations. Configuration purpose implementation, needed to compile and run API, exposed to consumers of library. Compile only, needed only at compile time. Runtime only, needed only at runtime. Test implementation, needed for tests. Annotation processor, needed for annotation processing. Step 11, implementation versus API. Use implementation for most dependencies. Example: dependencies, implementation, com.fasterself.jackson.core, Jackson databind. Use API when building a library and exposing dependency types to consumers. Example: plugins, ID, Java library, dependencies, API, org.apache commons, commons lang 3, 3.14.0. Beginner rule. For applications, use implementation. For libraries, use API only when needed. Step 12. Compile versus implementation. Old Gradle projects may use compile, org springframework.boot, Spring Boot starter web. Modern Gradle uses implementation, org.springframework.boot, Spring Boot starter web. Important: Compile is old deprecated. Use implementation instead. Step 13. Add JUnit test dependency. Example. Dependencies, test implementation, org.jutitr, Junit Jupyter, 5.10.2. Test. Use JUnit platform. Run tests. Gradle test. Test reports. Build, reports, tests, test. Index.html. Step 14. Build a Java application. Example, build Gradle. Plugins, ID, application. Repositories, Maven Central. Application, main class, type com.example.main. Run. .sgradle run. Package. .gradle build. Step 15. Build a Spring Boot application. Example. Plugins. ID. Java. ID org Spring Framework Boot. Version 3.5.0. ID IO Spring.dependency management. Version 1.1.7. Group equals com.example. Version equals 0.0.1 snapshot. Java toolchain. Language version equals Java language version of 21. Repositories, Maven Central. Dependencies. Implementation, org Spring Framework Boot, Spring Boot Starter Web. Implementation, org Spring Framework Boot, Spring Boot Starter Data JPA. Runtime only, org PostgreSQL, PostgreSQL. Test implementation, org Spring Framework Boot, Spring Boot Starter Test. Test, use JUnit platform. Run app. Gradle, bootRun. Build executable jar. /Gradle, bootJar. Output. Build/libs my app 0.0.1-snapshot.jar. Step 16. Understand Gradle build lifecycle. Gradle build lifecycle has three main phases. Initialization, configuration, execution. Meaning. Phase, purpose. Initialization, finds projects. Configuration, evaluates build scripts. Execution, runs selected tasks. Example. Gradle, build, flow. Read settings.gradle. Configure build.gradle. Run build task and dependencies. Gradle's official lifecycle docs describe these phases as initialization, configuration, and task execution. Step 17. Clean build. Command. Gradle clean build. Meaning. Clean equals delete old build output. Build, compile test package. Use when. Check, build output is stale. Check, generated classes are wrong. Dependency conflict was fixed. CI build should start clean. Step 18. Skip tests, temporarily. Command. Gradle build xtest. Meaning, build project but skip tests. Use carefully. Good for. Quick local package. Troubleshooting build issue. Avoid in CI unless intentional. Step 19. Show dependency tree. Command. Gradle dependencies. For specific configuration. $Gradle dependencies. -configuration runtime class path. Useful for debugging. Version conflicts, duplicate libraries, transitive dependencies, dependency upgrades. Step 20. Debug dependency conflict. Example issue. No such method error. Class not found exception. Version mismatch. Use /Gradle dependencyInsight -dependency Jackson databind. Example. Gradle dependencyInsight -dependency Spring Core. This shows. Check. Where dependency comes from. Check. Selected version. Check. Conflicting versions. Transitive path. Step 21. Exclude transitive dependency. Example. Dependencies, implementation, example, legacy client, 1.0.0. Exclude group commons logging, module commons logging. Use when. Dependency brings old library. Security vulnerability exists. Duplicate locking libraries conflict. Wrong version appears. Step 22. Force dependency version. Example. Configurations.all, resolution strategy, forcecom.fathernom.core.jackson databind 2.17.2. Use carefully. Better approach. Use BOM, use platform. Align versions properly. Step 23. Use BOM for version management. BOM means Bill of Materials. It manages compatible dependency versions. Example: dependencies, implementation, platform, org.springframework.boot, Spring Boot dependencies, 3.5.0. Implementation, org.springframework.boot, Spring Boot Starter Web. Implementation, org.springframework.boot, Spring Boot Starter Data JPA. Benefits: fewer version conflicts, consistent dependency versions, easier upgrades. Spring Boot's Gradle docs note that dependency management can use either the Dependency Management plugin or Gradle's native BOM support. Step 24. Use Gradle properties. Gradle.properties can store build settings. Example: org Gradle JVMargs equals XMX2G, org Gradle parallel true, org Gradle caching true. Useful for tick memory settings, parallel builds, build cache, project properties. Project property example: app version equals 1.0.0. Use in build Gradle. Version equals find property app version. True 0.0.1 snapshot. Step 25. Use Java toolchains. Java toolchains help Gradle use a specific Java version. Example: Java toolchain language version equals Java language version of 21. Benefits: consistent Java version, fewer local setup problems, better CI builds, easier upgrades. Example: developer has Java 24 installed. Project uses Java 21 toolchain. Gradle builds with Java 21. Step 26. Multi-module Gradle project. Example: structure: e-commerce system, settings.gradle. User service, wing, build Gradle. Order service, wing, build Gradle. Common, build Gradle. Settings.gradle. Root project.name equals e-commerce system. Include user service, include order service, include common. Gradle multi-project builds use settings.gradle.kts to include subprojects by name. Step 27. Share common dependencies. Root, build, Gradle. Subprojects.applyplugin.java. Repositories, Maven Central. Java. Toolchain. Language version equals Java language version of 21. Use for common Java version, common repositories, common test setup, common shared plugins. Be careful. Do not put every dependency in root build.gradle. Each module should declare what it actually uses. Step 28. Project dependency between modules. Example: dependencies, implementation project, common. Meaning: this module depends on common module. Example: order service, common. Used for check shared DTOs, check utility classes, common exceptions, check shared security models. Step 29. Custom Gradle task. Example: tasks.register hello, do last println hello from Gradle. Run ./Gradle hello, output hello from Gradle. Custom tasks are useful for code generation, code check, file copy, version printing, environment checks, build automation. Step 30. Task dependencies. Example: tasks.register, prepare app, do last, println, preparing app. Tasks named build depends on prepare app. Now, Gradle build runs. Prepare app build Gradle tips for Spring Boot developers. Tip 1. Use bootRun. $Gradle bootRun runs Spring Boot app locally. Tip 2. Build executable jar. .gradle bootJar. Run jar. Java jar build libs app jar. Tip 3. Use runtime-only database driver. Good. Runtime-only org.postgresql, PostgreSQL. Reason: PostgreSQL driver is needed at runtime, not compile time. Tip 4. Use test implementation for tests. Test implementation org.springframework.boot, Spring Boot starter test. Reason: test libraries should not go into production runtime class path. Tip 5. Use dependencyInsight. .gradle dependencyInsight - dependency logback. Useful when logging conflict. Old version appears. Vulnerability scanner reports dependency. Class path issue happens. Gradle troubleshooting problem 1. Permission denied for Gradle. Error. Permission denied. Gradle. Fix. Mod plus X Gradle. Then. Gradle build. Problem 2. Gradle uses wrong Java version. Check. Gradle minus version. Fix using toolchain. Java. Toolchain language version equals Java language version of 21. Or set. Export Java home equals path to JDK. Problem 3. Dependency not found. Error. Could not find dependency. Check. Repository exists. Dependency coordinates are correct. Internet access. Company proxy. Private repository credentials. Example. Repositories, Maven Central. Problem 4. Tests fail during build. Command /Gradle test. Check report. Build reports tests test index.html. Temporary skip. Gradle build -x test. But fix tests before production. Problem 5. No such method error. Usually caused by dependency version conflict. Debug. Gradle w dependencyInsight - dependency library name. Fix. Align versions. Check use bomb. Check exclude old transitive dependency. Check upgrade dependency. Problem 6. Build is slow. Try. Gradle build scan common causes. Check too many tests. Check no build cache. Dependency downloads. Annotation processing. Check large multi-module project. No configuration cache. Optimization options. Org Gradle caching true. Org Gradle parallel equals true. Gradle best practices. T. Use Gradle Wrapper. Commit wrapper files. Use implementation instead of old compile. Use Java toolchains. Use BOM for version alignment. Avoid hard-coding secrets. Keep dependencies minimal. Use runtime only for database drivers. Use test implementation for test libraries. Use dependencyInsight for conflicts. Avoid putting all dependencies in root project. Keep multi-module boundaries clean. Enable build cache carefully. Use meaningful task names. Run clean builds in CI. Check dependency vulnerabilities. Avoid version conflicts. Prefer official plugins. Common beginner mistakes. 1. Using system Gradle instead of wrapper. Bad. Gradle build. Better. Gradle build 2. Using compile dependency. Bad. Compile org Spring Framework boot Spring Boot starter web. Better. Implementation org.springframework.boot Spring Boot starter web 3. Adding every dependency to implementation. Better. Runtime only org.postgresql PostgreSQL. Test implementation org.junit Jupyter. Compile only org.project Lombok. Annotation processor org.project Lombok. 4. Ignoring dependency conflicts. Use /Gradle dependencyInsight dependency name 5. Putting secrets in build.gradle. Bad. Password equals my secret. Better. Use environment variables or CI/CD secrets. 6. Not checking Java version. Always check. Gradle version 7. Not understanding multi-module dependencies. Bad. Every module depends on every other module. better. Only depend on modules you actually need. Gradle interview questions. 1. What is Gradle? Gradle is a build automation tool used to compile, test, package, and manage dependencies for applications. 2. What is build.gradle? Build.gradle is the main build script that defines plugins, repositories, dependencies, tasks, and build configuration. 3. What is settings.gradle? Settings.gradle defines the root project name and included subprojects. 4. What is Gradle Wrapper? Gradle Wrapper allows a project to use a specific Gradle version without requiring Gradle to be installed globally. 5. What is a Gradle task? A task is a unit of work such as compiling code, running tests, creating a jar, or publishing artifacts. 6. What is the difference between implementation and API? Implementation hides dependency details from consumers. API exposes dependency types to consumers of a library. 7. What is runtime only? Runtime only is used for dependencies needed only at runtime, such as database drivers. 8. What is test implementation? Test implementation is used for dependencies required only for test code. 9. How do you debug dependency conflicts? Use .gradle dependencyInsight dependency name 10. How do you run a Spring Boot app with Gradle? Use .gradle bootRun 11. How do you build a Spring Boot jar? Use $gradle bootJar 12. What is a multi-module Gradle project? A multi-module project contains multiple subprojects managed by one root Gradle build. Gradle roadmap beginner level. Learn, Gradle Wrapper, build.gradle, settings.gradle, plugins, dependencies, common tasks, build, simple Java Gradle project, intermediate level. Learn, Spring Boot plugin, bootRun, bootJar, dependencyInsight, Java toolchains, testing, custom tasks, build, Spring Boot REST API with Gradle advanced level. Learn, multi-module builds, convention plugins, build cache, configuration cache, publishing artifacts, CI/CD optimization, build, multi-module microservice system, 30-day learning plan week 1, Gradle basics. Learn, Gradle Wrapper, build.gradle, settings.gradle, tasks, plugins, repositories. Practice. Create simple Java project and run build. Week 2, dependencies and testing. Learn. Implementation. Implementation only. Test implementation. Dependency tree. dependencyInsight. JUnit setup. Practice. Add dependencies and run tests. Week 3, Spring Boot with Gradle. Learn. Spring Boot plugin. bootRun. bootJar. Dependency management. PostgreSQL driver. Profiles. Practice. Build Spring Boot REST API using Gradle. Week 4, multi-module and troubleshooting. Learn. Settings.gradle modules. Project dependencies. Root build.gradle. Custom tasks. Dependency conflicts. Java toolchains. Practice. Create multi-module Gradle project. Real-world example. Spring Boot e-commerce API. Architecture. React frontend. Spring Boot API. Gradle build. PostgreSQL. Docker. CI/CD pipeline. Gradle responsibilities. Compile. Java. Run tests. Manage dependencies. Create executable jar. Support multi-module build. Integrate with CI/CD. Package application. Example modules. E-commerce, user service, order service, payment service, notification service, useful Gradle commands cheat sheet. www.gradlo-v. Shows Gradle version. .gradle tasks. Shows available tasks. .gradle clean. Deletes build output. .gradlo build. Builds project. .gradle test. runs tests. .gradle bootRun runs Spring Boot app. .gradle bootJar creates executable Spring Boot jar. .gradle dependencies shows dependency tree. .gradle dependencyInsight dependency Jackson debugs dependency version. .gradle build-x test builds without running tests. Final summary. Gradle is an important build tool for Java and Spring Boot backend developers. Important concepts include Coder, Gradle Wrapper, build.gradle, settings.gradle, plugins, repositories, dependencies, tasks, Java toolchains, testing, Spring Boot plugin, multi-module builds, dependency troubleshooting. Backend developers already understand. Check Java, check APIs, check testing, deployment, microservices, CI/CD. This makes Gradle easier to learn. Key idea. Gradle automates the build process so backend developers can compile, test, package, and deploy applications consistently.